Good morning, everyone. My name is Dr. Shivali Verma, and today we are dealing with the subject engineering physics and its application, in which today I am taking the unit third topic, Ruby laser. Okay, so you have seen a Ruby lasers pumping element, which is known as a, krypton lamp. Okay, so first we have start with the introductory part of the Ruby laser. What is basically Ruby laser is? Ruby laser is a first successfully operated laser, and it is made by the TH Maniman in 1960, and it is first solid state laser. So, as you know that in any laser, the first on the point of view of construction, the first thing is the active medium. What is the active medium? Active medium is basically a medium where we are performing the laser action. So, in Ruby laser, what we are doing actually, we are making active medium with the help of chromium oxide, as you see here, with the help of chromium oxide, which is known as a Al2O3, and in which we doped it with the chromium ions. How we can dope it with the chromium ions? We can do one thing. We can take aluminum oxide and chromium oxide, and the percentage, whatever the percentage of aluminum oxides, it's 0.05% weight of chromium oxide add inside the aluminum oxide. It means this the simple thing is that suppose that you have a 1 gram of Al2O3 means aluminum oxide, and you can take 0.05% of chromium oxide and mix together with aluminum oxide. Then what process is going on the aluminum ions, which is Al3 plus ion, is replaced by the chromium ion through this doping, and the color of the crystal is changed. It is slightly become a pink or red, which is depending upon the concentration of chromium ions. So in this way, we have create the first component of the laser, and which is known as a active medium. Now, what after that we will do? Then we can make a crystal. This we take this crystal and make we can cut it in the form of a cylinder, and the usually we can take its 2 centimeter to 30 centimeter its length, and the diameters, the cross section diameter, we can take sometime 0.5 centimeter to 0.25. These are the basically very typical values of the ruby laser. Now the ruby laser is actually perform in a very high temperature circumstances or surroundings. So we have to be cool this apparator with the help of a nitrogen, liquid nitrogen. Okay, so this is all about the active medium. Now, what is the active centers? What are the active centers basically? So, active centers, when you replace the aluminum oxide by the chromium oxide, the what happen actually? There are few metastable states of chromium ions constructed inside the crystal, and therefore only chromium ion can take place in the active in a ruby laser production. Aluminum and oxygen is only going to be supported. Therefore, the chromium ion in this laser is behave like a active center. Now, as we know that the third major component for the ruby laser is a pumping source. Now here we are using, either we can use somewhere the people are using a krypton lamp. Here we are using a xenon lamp. But how we use this xenon lamp in ruby laser? So what we are doing, we are we can hold that ruby crystal in xenon lamp in a helical shape. Means that we can tie a xenon lamp around the ruby laser in a helical shape, as you have seen over here in this diagram. That ruby laser rod is here, and this sort of thing is actually a xenon lamp, which is helically placed over the ruby laser. Yeah, or we can say that the ruby laser is covered by this xenon lamp through the helical shape. We can say that in a helical form. Okay, so the third most important component, which is must for the lasers, and that is known as a optical resonator. So how we can create the optical resonator? As we know that the optical resonator is a combination of two mirrors, in which one is 100% refractive and another one is a 50% refractive. So what we are doing here, we are polished and the ends of the ruby crystal with 100% with the silver. One hand we have polished 100%, and another one we have polished, means one hand we can polish completely by the silver, and another hand we can partially polished by the silver. And in this way, we got a optical resonator for our ruby system. Okay. So you have seen here, this is the helical shape xenon lamp, and now moving towards the next thing. So these are the components. Actually, these are the cavity. This is the cavity in which we placed our ruby laser. This is ruby crystal rod, and it is our pumping element, which is known as a xenon lamp in this condition. Okay, so now we are moving towards the working. What is the working of ruby laser? So when ruby laser is basically three level pumping laser, what happen actually, whenever when we are we doped chromium ions inside the aluminum crystal, there are three levels are set for the chromium ions. What the threes level are: one is a ground state, which is known as a E1. Another is a excited state, it is known as a E2. Next excited state, which is known as a E3. E3, and one more excited state, but it is not a excited, it is a metastable state, and which is here, which is depicted by E4. So E4 is basically this E4. I have written over here E2, so you have to just change it by the E4. Actually, this is not E2. We can measure it by E. We can say that it is a. I can just make some few changes here. So this is not E2. This E2 is basically is our excited state, and E4 is our metastable state. And E2 and E2 and E3 are the excited states. Okay, got it. And E4 is a metastable state, and even is a ground state. So E2 and E3 are the bands, and E3 E3 is this. Okay, so this one is our E3. And what is E4? E4, yeah, we can replace 4 by 2. Okay, 4 by 2. Okay, so this E3 and E4, you have seen here E3 and E2, sorry, they are considered as only a one level because they are very close to each other. So we can treat E3 and E3 and E2 as a pumping state or a simple excited state. Okay, pumping state, you people know that first part, our ions or our active center go where in a pumping state. So E3 and E2 are the pumping state, and they are very nearby. That's why we are known as an excited state or a pumping state. After that, E4 is our metastable state, and E1 is our ground state for the chromium ions. Okay, so now next step, how this Ruby laser, how this all the pumping and all the metastable state or population inverters are achieved. So as we place Ruby crystal inside the xenon flash lamp and we start flash lamp, there are a number of white light photons are coming through or incident over this ruby crystal. And after that, what happened, this inside this ruby crystal, this chromium ions are sitting, and they start absorbing these photons, or we can say that you have seen here these photons are coming in from the xenon lamp, and they are going to be absorbed through the chromium ions. And chromium ions is only show excitation for two colors. One is a green and another one is a blue. So in this way, the chromium ions are excited, start exciting, they start exciting in energy level E2 and E3. Okay, and these levels, as I said, that these levels are basically a pumping level. So this process is basically known as a absorption. This process is basically known as what? It is known as a absorption. And this absorption is because for green and blue color, so the wavelength is nearly about 66600 angstrom and 4000 angstrom, which is nearly about green color light. And these are the wavelength of green color light and blue color light. Okay, so what actually happen, electrons, now the ions, chromium ions are going to jump in the energy state E2 and E3 by absorbing the photon of 600 angstrom and 4000 angstrom in its pumping state, and this process is known as a absorption. Just I want to tell this thing. Now next, and then what? As I said that these are known as a pumping level. So in next, what happened after in a pumping state means E3 and E2 both are the pumping state over here. So after this pumping state, the ions stay here for 10 to the power minus 8 second, not more than that, because as you know that the time period of any excited normal excited state is 10 to the power 8 minus 8 second. So a chromium ion stay here for 10 to the power minus 8 second, and after that they start jumping to their ground state, but few of them are jump into the ground state, and maximum of them are trapped by this metastable state E4. So E4, the number of chromium ions increased in energy state E4, and while the jumping at a ground state is very minimum, very low, therefore ground state is nearly about empty, and E4 is going to be populated by the chromium ions. As a result, the between E4 and E1, and now why this chromium ion stay in a E4 for a longer time period, because you know that the matter stable state having a time period of 10 to the power minus 6 to minus 6 second to the minus 3 second. So here the chromium ions stay for very long time, and in this way the ground state is nearly empty, and the metastability E4 is populated with the chromium ion. In this way, the our most important condition for producing the laser is generated, which is known as a population inversion. Okay, so now the population inversion is generated between the E4 and E1. Now what happened? Now the things are how we can achieve the this. So between what happened, a few electron, few ions, sorry, few chromium ions came back to E4 to E1 by the process of spontaneous emission, not a stimulated emission. Take one thing in this mind, and this In this way, a photon of frequency or wavelength, 6943 angstrom is generated. And now now one photon, this we are now in on this stage. Actually, what happened now, you can know this thing that first we can produce a population, we can produce material real, then we can give its energy and generate a population inversion. After a population inversion, a single photon is generated through the spontaneous emission inside the ruby rod, and they can travel in a ruby rod out parallel to the optical axis, and they start exciting the other photons which are trapped in a E4 energy level. And in this way the because these photons, actually the first photon is generated through the spontaneous emission, but this photon is excited other photons which are other chromium ions, which are in the E4 energy level. So now this, because this first photon is work as a stimulator for other chromium ions to come back in its ground state. Therefore, this whenever the now the whatever the emission is generated between our E4 and E1 is basically through the stimulated emission, not by the spontaneous emission, because is in a spontaneous emission it's a sudden emission. So one photon is generated to the sudden emission, but other photons are generated due to the stimulation of the this photon which is generated to the spontaneous emission. So that the now the chromium ions coming from the E4 energy state to E1 energy state through the stimulated emission. And whenever the photons are coming through the stimulated emission, you know that the all the photons are having a same energy, and all the photons having a same frequency. And in this way we can get a very very dense photons. As you know that now this they have you seen here, or you can see here that few photon these photons, whenever the photons one photon is generated of 6943 angstrom wavelength, they start traveling in a optical cavity, and due to the optical resonator they are moving to and fro and to and fro inside the cavity, and in this way they can enhanced by each movement. And once the loss and gain on on this mirror, on we can say that partially silver mirror, the laser coming out from the this area. So in this way the helium neon laser is produced, and we can know that this color, the color of the helium neon laser is a red, and its wavelength is a 6943 angstrom. The we can say that the output wavelength is 6943 angstrom, and the power is the output power is 10 rise to power of 4 to 10 rise, okay, to 6 watt, and it is in the form of pulses. We can say that this laser is not a continuous laser, because you know that three level pumping, the laser produced by the three level pumping is always a pulse laser. Okay, so what are the advantage of the ruby laser? So advantage of ruby laser is on the basis of if we can say that for the cost point of view, ruby laser is very economical. Second thing, beam diameter of ruby laser is completely less than the CO2 laser. Third one is that the output of the ruby laser is not as large as helium neon gas laser. Ruby laser is in a solid form, therefore no chance to wasting the material of active medium. And the construction and working of the ruby laser is a self-explanatory, means it is very easy, not too much tough. Now what are the disadvantage in ruby laser? Significant stimulated emission occurs until at least half of the ground electron has been excited to the metastable state. Yeah, or we can say that the ground state is not always zero. That's why we need more and more energy to stimulate the particle from sorry to excite the particle from ground state to the excited state. Therefore its efficiency is very low, means we are using more power for excitation, but out we are getting very less power at output side. Okay. Second thing is that optical cavity of ruby laser is short as compared to the other laser. Ruby laser is not a continuous laser, it is a pulse laser, which is also again a very big issue. Third point is that there are some crystalline imperfection present in the ruby laser. Crystalline imperfection is like that suppose the the whole crystal, in the whole crystal, the chromium and aluminum ions are not aligned with each other, or not in a in like that they are not in a sharing the same band. Sometimes what happen, aluminum ions are here, and we need a chromium ions below it, but sometimes what happen, the aluminum ions come with the aluminum ions and there is no chromium ions. So the energy is invested, whenever the energy is coming, they are searching the chromium ions. They are not, aluminum ions are basically not excited by this blue color light or a green color light. So energy is invested, we are sending the energy, but it is not getting by the active centers. So crystalline imperfections are also one of the most important reason or disadvantage of ruby laser. So what are the applications of ruby laser? Ruby laser we can use to decorate pieces, artistic displays. We can use a school, college, university science project. We can use for the holography, industrial cutting and welding. Due to the low output power, they are class one laser. So many users are for the toys of childrens. Okay, so ruby laser, some few people are using nowadays for laser medication, like scar treatment, tattoo removing, yeah, induce healing. And so these are the basically the ruby laser. You have seen here tattoo removing and scar technique which are using by the ruby laser. This lady having a lots of patches on her face. After the treatment, it is removed. Similarly, here is a tattoo, but after the treatment, the tattoo is removed. So now ruby laser having lots of uses. So today we have completed topic ruby laser. This is the eye treatment. Thank you very much.